Yeah, welcome everybody to CSCI 1. Let's do it. The reason I don't make my presentations full screen is because I switch around between a bunch of different programs during the lecture. And then also, I get much cooler pens this way. They give me rainbow pens, and so obviously, I'll keep it like this. Yeah, everything I'll do today will be available for you on Canvas after the lecture is over, eventually. I'll put the recording up, I'll give you all these slides as a PDF, and then any code that I write, you'll get that too in some form. Today is going to be that standard boring first lecture, I think, at least the first bit of it. So I'll explain who I am, I'll introduce myself, we'll talk about the class and the syllabus and try to stay awake. And then I promise we will get into computer science. All right, we'll talk about the history of computer science so that we're all on the same page. And then half of this class is kind of like a philosophy class. And so we're going to learn a philosophy topic as well. We're going to talk about ethics because that applies very well to computer science. So that's what we're going to do. And I guess let's get started. I'll take attendance eventually, but not right now. All right, so let me introduce myself first. Hello, everybody. If you haven't met me before, my name is Lawton Nichols. I use he, him pronouns, and I will respond to whatever you would like to call me. Call me Mr. Nichols, call me Dr. Nichols, call me Professor Nichols. But honestly, I would prefer it if you just dropped all those and called me by my first name. Just call me Lawton. I want to earn your real respect. Fake respect with these titles. All right. So a little bit about my background is that I went to Fresno State for my undergrad degree. I got a bachelor's in computer science, and then I went to UCSB, UC Santa Barbara, for grad school. That's where I got my master's and PhD. And all of my degrees, luckily, are in computer science. So hopefully that means I can teach you something. All right, we'll find out this semester. All right, and here's a picture of my cat as a kitten. I have dedicated my firstborn son to the cause of computer science. His name is Alonzo. I named him after a famous computer scientist whose name was Alonzo Church. And if you haven't heard of him before, go look him up on Wikipedia. But he was the PhD advisor to Alan Turing. Hopefully you've definitely heard of that name. All right. So yeah, I like to do normal human things as well as teach and program and stuff. I like to dance. I like to play guitar. I like to hike. So talk to me about those things as well if you'd like. But yeah, that's a little bit about me, and I'm excited to get to know you as well throughout the semester. And I do just want to say thank you in advance for putting up with me. I know we live in this weird post-COVID world now. We will all get through the semester together. Okay? And yeah, with that, let's just get started. Let's move right into the syllabus. I'm going to go as fast as I can possibly go because I don't like going over this stuff either. It's boring for me too. Make sure to read the syllabus. That's on you to read it, okay? Anything I don't say, you still have to pay attention to. So, first of all, this is an in-person class, and I have to take attendance and drop people, sadly. So we'll do that in just a little bit. I'll show you the cool way that I've come up with to take attendance in this class. And my drop policy is going to be, if you miss the first class, I have to drop you. And you're all not going to get dropped because you're here. But if you miss 3 consecutive classes after that, then I'm also going to drop you. Okay, because by that time you haven't been showing up. Okay. I will excuse you, of course, if you have a good excuse. So if you have like a doctor's appointment or something, just tell me beforehand, and that won't count towards the 3 or something. All right. 3 consecutive classes, though, I will unfortunately have to drop you. So just keep that in mind. And now let's talk about expectations. So this class is not a major level computer science class. This is a GE class. Right? That's why we all signed up for it. So it's not meant to be as difficult as like a fancy programming major level computer science class. But you do have to do a bit of work, all right? So just want to make sure you know what you're getting yourself into. There is going to be a decent amount of work in this class because it's hard to learn programming for the first time. I assume that most of you have never done that before, and it's a completely new way of thinking, all right? It's going to melt your brain a little bit, and I have to give you work to practice it, all right? The more the better. It's going to be fun, though, I promise. That's why I love it. So, yeah, programming is a completely new way of thinking. It's going to be okay, though. I'll get you through it. Yeah, just the work in general, it might get a little tedious if you're waiting until the last minute all the time. Because, like, with computer science assignments, if you have not figured this out yet, if you haven't taken a computer science class before, like, all the topics, they kind of you have to sleep on the questions a lot. You have to sleep on the problems, and then you wake up, you have a flash of genius. So, like, you have to start early on the assignments in this class. That's my recommendation for sure. Okay, so definitely don't wait until the last minute. But yeah, you're gonna learn how to program. I think that's exciting, and it's just kind of a new way of thinking, which means you don't have to memorize anything to do well on the tests in this class as well. That's kind of cool. Like, it's just going to be, I'm going to teach you how to think like a computer, and then you will program, and it will be great. Right? The other half is essay writing. Right? Yeah, I don't want to scare you away or anything. I just want to tell you what you're getting yourself into, and I will, of course, be here to help you. Okay? Yeah, just let me know if you guys have any questions throughout this entire lecture. I like to run my lectures like a discussion, so like you don't even have to raise your hand. If there's a pause, just like shout out to me, and I will get to you. Okay. The next thing I want to talk about is if you need like a laptop at home or even like a little hotspot router, the library has written those out to you guys. So you do need a computer to do the work at home in this class. So make sure you're taking advantage of that if you need it. And then yeah, let's just keep on going. I'm gonna go as fast as possible to get through all this. Okay. So what is this class going to be about? So it's kind of two pieces. I'm going to teach you to program. So that's thinking like a computer, computational thinking is that word. And then this is also a critical thinking GE class, right? And so programming is part of that. You're going to learn to think in a cool new way. But then I'll also teach you how to argue well, how to like think logically and like notice when things are wrong. Fallacies is one example of that. And have you have little mini debates with each other just to like learn how to get your points across, right? And all of that's going to help you program. So this is a very interesting class. I think it's a cool combination of ideas, and we're going to tie back all of this critical thinking knowledge to computer science in some way. So like there's plenty of social issues and ethical issues in computer science that we can talk about, and I'll have you write essays about. AI, for example, is a hot topic, right? We'll talk about that eventually. So yeah, that's what you're going to learn about. And I just want to emphasize that this class is for everybody. So if you want to become a better programmer, perfect. Take this class. If you just want your GE critical thinking class, that's cool. I am here to give you that credit. Yeah. And then if you already are drinking the Kool-Aid of computer science and like you like programming already, but maybe you want to know more. Like you want to know more about the outside world, the bigger picture, the world around computer science, rather than just like sitting in a cubicle writing programs all day long. Again, this class is free. So this class has something for everybody, I think, and I hope that you enjoy it. So, all right, let's do that syllabus. I will go to it. Hopefully you found it. You have to go to the modules page to unlock everything on our Canvas. So go there, and then like I'm forcing you to look at all these pages, right? And then here's the syllabus page. So here it is. I will scroll right on down to the part you care about, the grading part. Right? So here is what your grade is going to be made up of. Let's go in order. So the first thing, an easy 5% of your grade are these things that I call check-in surveys. All right, I'm going to give you one every week, and just the first one, just like asking you to introduce yourself to me. But after that, it's eventually going to be me asking you like, what's going wrong? What are you struggling with? How do you think you could do better? Stuff like that. So I'm forcing you to psychoanalyze yourself, and it's a win-win for both of us. Like you figure out how to help yourself, and then I figure out how to help you too. So it's great. An easy 5% of your grade. Just do those every week. That's check-in surveys. Sadly, we have to write essays in this class, and to get this to it's the UC's fault, guys. To get this to transfer to a UC, you guys have to write 6,000 words of essays this semester. So like 6,000 words total, I mean. Okay? And that's going to be 30% of your grade. All right? Written essays will make up that much. I don't like grading them either. I never thought I'd have to grade essays as a computer science professor, but here we are. But we're going to get through it together. And then the other half of the class is going to be programming, right? So I'm going to give you programming assignments as well. Most weeks, those are going to make up 30% of your grade as well. So it's like half essays, half programming assignments, okay? That's what's going to happen. The languages that we're going to learn in this class are, the first one we're going to learn is we're going to start us off with, I'm going to start you off with an easy language called Scratch, and then we're going to get into a language called Python that is used by millions of programmers, all right? It's a very popular language. We'll get into that eventually. And I do want to say, though, if you are already a computer science major or you've somehow taken a computer science class already, then I'm going to give you different programming assignments for the first half of the semester, because the ones that I give to everybody else that are first-time programmers would be too easy for you. So I want to make sure there's you're still learning something, right? So just keep that in mind. And yeah, I think that's most of it. There's going to be one midterm halfway through the semester. There's like 16 weeks of classes and then a finals week, so like I'll try to have it on week 8, I think, maybe the Wednesday of week 8. 15% of your grade will be that, and then 20% of your grade will be the final at the end of the semester. Right, so that's your grade breakdown. I think that's the most important thing you want to know right now. Are there any questions about that? All right. So yeah, just yell at me if you have any. There also is a recommended textbook for this class. It is not required though. So this guy, if you get it, you don't have to. You'll notice that a lot of my lectures are based around the topics in this book. It will only help you to get this book. It will help you with the essays that you write in the class, not so much the programming assignments though. So consider looking into it, but it is not required. You don't have to buy it. There will also be extra credit assignments. I will give you a few throughout the semester, just like as normal assignments. And there's also a cool computer science club on campus called the ACM Club. Have we heard of that? Maybe some of us. Join our Discord. There's a link to join the ACM Club's Discord as well, and they will be announcing workshops. I will give you half a percentage on your final grade towards extra credit for going to any technical ACM Club workshop. A board game night does not count. But like if they're teaching you something, I will give you extra credit for going to those, right? But I'll cap you off at 10% extra credit. Some combination, I'll cap you off at 10%. That's a letter grade's worth of extra credit in the class. Okay. So that's the plan for that. And then the final exam, because this is an in-person class, there's like a big long table that you go and look up when the final exam is. And so I think I read the table right. Please correct me if I'm wrong. But I believe that our final is going to be on the Monday of finals week, the 19th of May, starting at the same time as class, but going a bit longer than class normally goes. Okay, that's what I think it is. Please yell at me if I messed that up. I think that's the right one though. So yeah, I think that's the most important slide. Are we good? To you at least, not to me. All right, let's talk about some policies of mine. So I'm pretty lenient with late submissions. I'll accept late programming assignments and check-in surveys up to the last day of instruction, which is the week before finals week, the Friday. But the give and take is going to be that I will take half credit off the second you turn something in late. Okay, so you can get stuff in if you have a bad week. Just like get it in at the end of the semester, 50% is much better than 0. All right. The one thing I won't accept is late essays, because if you want to make up a bunch of essays towards the end of the semester, like that's going to be horrible for me. I don't want that, so I'm not going to accept late essays. Okay, so you have been warned. That's that. Let's talk about due dates as well. So the due dates in this class are a little different. So every assignment in this class, except for the check-in surveys, which we do at 5:30, every assignment in this class is going to be due at 5 p.m. All right, so get that in your brain. Whatever you see it on Canvas, it's due at 5 p.m. All right, that's when it's due, because technical issues arise in computer science. So I want to be awake to help you as you're trying to turn in an assignment if something happens. All right. So that's the reason I have my due dates at 5 p.m. So just like you be warned, it's not midnight, it is 5 p.m. for all of the due dates. Okay? We're going to remember this, right? All right. I do make some exceptions for certain students. If you're a working student, if you work at least half time, 20 hours or more per week, school does not count. If you're taking 20 units, that's your fault, right? But some of us do need to work. So if that's you and you're in this group, then I will give you an extra 7 hours to do all of your assignments in the class. So it really will be due at midnight for you if you work at least half time. If you work at least full time, or you do something that is the equivalent of a full-time job, like you care for a child, something like that, then I will give you an extra 15 hours on all of your assignments in the class. Okay, so you can either stay up late or wake up early, and you'll have some extra time to get it in. So I hope that we can agree that the people in these groups deserve the extra time. And yeah, just let me know if any of those apply to you. You can send me a message on Discord or Canvas or something. And yeah, I think that's what I wanted to say. These are assignment extensions, not exam extensions. Okay. So that's my due date policy. Again, just shout out if you have any questions about this stuff. I will drop your 3 lowest programming assignments if you have a bad week. Then it'll be like it never happened. Do them all though, because they build on top of each other. And then yeah, let's talk about how to get help. So let's talk about Discord. So we have a class Discord, and I hope we have all been able to join. Right? Have you all found the link? That's this Discord info page. There's a link to sign up for it, or like make an account. Let me show it to you. This is the way that I want you to ask questions in this class. This is what happens when you don't open up Discord for winter break. You can do a little guy. We're moving at the speed of JavaScript. But yeah, when you get on the Discord, at least, there's going to be a bunch of channels, and when you start out, there's only going to be 2 when you join the thing. Whee! There's only going to be 2. It's going to be the welcome and the guide channels. You have to follow the instructions in the welcome channel. You scroll all the way up. You click the 100 emoji. Then you click the dog emoji to add the CSCI 1 rule as well. Make sure to change your nickname to include your last name. Otherwise, I'm going to kick you out of the server. And then add your pronouns if you want. And then here's the ACM Club's Discord. You can join that and get information about their workshops. Okay, so that's our Discord. And then like clicking all those buttons is going to open up all these other channels like general, and then here's one just for our class, CSCI 1. Okay, so encourage you to use that and ask questions as much as possible publicly to your peers, like when it's 3 a.m. and I'm asleep, so they can help too. But I do want you to use your judgment, all right? If you have a question about something that involves like an entire answer, a ton of code or something that would give an entire answer away or a lot of it, then please don't do that. Please ask a private question just to me, okay? So I don't want you to share a bunch of answers because that's not fair. So you can always ask me questions via private messages, direct messages. You can click on my name, right-click on me, and then go to message. I can't message myself, though. Click on me, click message. Okay, so that's what I want you to do. Do use Discord as much as humanly possible to contact me instead of Canvas or email, because I hope you can imagine how disgusting a professor's email inbox is. Yeah. But it's easy on Discord because you can see that I had some notifications. Like I can easily tell that there's somebody I need to get back to. All right, so that's Discord. I use that to discuss and to ask me questions. Let's also talk about office hours. So another place to get help is office hours. Here is the schedule I want to have. I'll be having some after class on Monday and Wednesday. At least that's the plan. These might change though, depending on like meetings that get assigned to me over the semester, but this is when at least I want to have my office hours, all these green boxes. So have some after the class on Monday and Wednesday. And yeah, here's the schedule, and just keep coming back to this page in case they change. All right. All of these office hours will be available for you to come on Zoom. So if you just want to go home and come to office hours still, you can go on Zoom, but there will also be some of them will be in my office as well, which is in this building down the hall. All right, so that's office hours. Please come to get help. I think that's what I wanted to say there. And yeah, I just want to, one last time, let's talk about getting help, because I assume a lot of you have never programmed before. It's going to be a weird new thing, all right? You're going to get stuck on a programming assignment, most likely, in this class. So I want you to ask for help when you need it. And so let's set up an amount of time, right? Let's start a timer. And let's say that if you have been stuck on a programming assignment or some other assignment, doesn't matter, in this class for at least 30 minutes. You've been stuck for 30 minutes. You have not made any progress at all. That's when I want you to ask for help, right? Come to office hours, ask a Discord question, go to the tutorial center. It's a great place. So you can get help and get over whatever is troubling you and on to the next thing, okay? That's the goal at least. So please, please, please ask for help. There is no virtue in staring at your screen for 2 hours working on something like I did as an undergrad. Don't be like me, all right? I think it would be a lot better if you just asked for help. So I do want to say, though, you're gonna notice that it's gonna take you 29 minutes to get a lot of things in this class, and then you'll have your flash of genius. That's how programming works. I'm excited for you to learn that. Yeah, I think that's all of the logistical information I wanted to talk about. Are we still good? Are we still awake? Question? Oh no, okay, cool. Let us keep on trucking then. So now I want to take attendance, all right? So I have made, as we are computer scientists, I have made a beautiful class website for us, all right? It's www.latinsclass.com, and I would like you to go there, please. You can also get the link on our Canvas. It's down here at the bottom, class website. So please go there. It'll take you here, and you log in like this, all right? Your username and your password for the class website right now are your last name, all lowercase, no spaces, no nothing, all lowercase, no hyphens, no nothing, plus an underscore, plus your student ID, all right? That's what your username and password are on the class website for you right now, So for example, if this is your last name and this is your student ID, this is your username and your password right now, okay? If this is your last name and this is your student ID, this would be your username and your password on the class website, okay? So please go there and log in and let me know if you're having any trouble. I'll come around and help you, all right? But get there now. We're gonna go and do attendance through the class website every day, all right? That's the goal at least. So usually we'll do this at the start of class, but yeah, everybody try to get on and let me know if you're having trouble. I will help you. I'll give you like a minute to get in the right spot. Do make sure to do this because gotta tell me if you're struggling, because if you get marked absent. I'm going to assume that we're all ready. Anybody raise your hand or get dropped? You have trouble? Good? All right. So here's what we're going to do. So you're going to go to your take attendance page and click any of these buttons that you want. It doesn't matter. Oh, it's going to make me log in too. That's funny. Cool. So like you click a button eventually. I just have to start the attendance. All right. So that's us. Begin. And now you can click whatever button you want. Oh wait, give it a second. There it goes. Now you can click whatever button you want and see if you were there and mark yourself here. All right. It doesn't matter which one. And then, because I assume that you're all just as anxious as I am, you can go to view my attendance the second you click that button and check that you were marked here, okay? So just go and confirm that if you would like. I'll leave this open just in case we're having trouble, but is everybody able to click a button and say that they're here? Are there any questions? Because I must drop you if you forget to do this. Please do it. I'll just leave it running while all the lecture is going, just in case there's issues. But like, tell me after class if you couldn't click the button, because we need to fix it. All right. But I want to move on now. Let us keep going. So this is a wonderful place. I hope that you enjoy the class website. I've got a few things for us. We're going to use it for a few things in the class. Okay, so now we can have a lecture though. Let's do it. So I guess the first thing I want to do is just like have you guys introduce yourselves to each other. So I would like to talk about something that I like to do in my classes that I've made my website around as well. So I'm going to have you guys get into little groups a lot in this class, like with the people sitting next to you, to work on little in-class exercises. Okay. So I'll like ask you questions to answer using, for example, this cute little iClicker app, which is a pun on the iClicker idea, which maybe you've seen one of these before. It's like a $60 remote control that you have to buy to like take a physics class or something. That's disgusting. So I've made you a free version of that on our class website. You're welcome. So like that thing. All right. So yeah, it's called peer instruction when I have you guys help each other and answer questions. All right. Every single piece of research has proven that it's the best way for you guys to learn in the class. So I promise, even if you're shy, it's worth it. All right. I'm going to force you to work with people. And yeah, we're going to have our first in-class exercise on the next slide. It's not going to require you to get into groups yet, but eventually I will towards the end of the class. And so it is an in-class exercise, which some people abbreviate as ICE. And our mascot at Clovis is, for some reason, a bowl called the Crush. If you know the origin story of that, please let me know, because it doesn't make sense to me. So obviously, I'm going to call our in-class exercises crushed ices. Cool. That's my fun example. All right, so when you see this, that means I have a question for you. All right, so what I'd like you to do, please, is go to the iClicker page, and I would like you to tell me what your major is in the class. It's, again, a thing where I start the question, you respond. All right. So tell me what your major is, please. Is it computer science, some other thing with a computer engineering, some other kind of engineering? Maybe it's mathematics. A lot of math majors are required to take at least one programming class. Maybe you're some other STEM major, or maybe you're something completely different. I'll give you a few seconds to type, or sorry, not type, but to click an answer, please. I assume we're already on the website. All right. It looks like we all got it. It's like 20 students enrolled, so that's perfect. Let's see what the makeup of the class is. All right, because I don't even get to see this. It's weird. They don't let me see your majors. Interesting. I love that graph, though. So a lot of us are computer science. So cool. Welcome, or computer engineering. And we got no math majors. Interesting. One other engineering, a couple other STEMs, and then an equal amount balances out. I love that. Something different like humanities or non-STEM. So I like that. Every single category here is different and interesting, and especially the non-STEM majors in this class, they're going to balance out the STEM majors, and I'm very happy that all of you are here. All right, so now I know a little bit about who's in the class. Here's another question for you. Begin. Have you ever programmed before? Because I'm going to ask you to do a lot of that in this class. You're not required to have ever learned programming, but let's see. Yeah. If I got sick, could you maybe teach the class in my stead? Let's see what we know already. And remember, those of you who have programmed before, you're getting different programming assignments for the first half of the class, just so that you learn something too. All right, let's see. Let's see what we got. Interesting. I like that. It's another pretty kind of graph. It's skewed. A decent amount of us, the majority, right, say that we've never programmed before. And perfect. I'm glad you're here. This is the class for you, right? You are not required to have ever known programming. It's my job to teach it to you. Some of us have programmed before, cool, and then some of us have recently programmed before, which is awesome. So those of you who picked B and C, please help out the students who picked A. All right. So yeah, I think that's what I want to do for the class at least. I'll keep that attendance running. I think we all got there. Let's actually have a normal computer science lecture. I'm ready. Are you ready? I want to teach you the history of computer science. All right, let's go through all the major breakthroughs to today, mostly, and just make sure we're all on the same page, just in case we've never seen all this stuff before. So let's talk about computation, right? Computer science is the study of computation. So, like, what's the first thing that let humans compute? Like the first tool that helped humans compute was probably the abacus, right? Back in the BC age, several thousands of years ago. Because all a computer is just like a tool that helps us perform a computation. And abacus is that for sure. So maybe that's the first computer. All right. we have to fast forward quite a ways until we get to more interesting ideas. But in the early 1700s, a nice dude named, with the last name of Leibniz, who maybe you've seen that word before, seen that last name before, because he also invented calculus. Among other things, he invented binary and something called formal logic, right? So binary is a number system that I will teach you eventually in the class. It's called base 2. That's another name for it, base 2. And what that means is you only have 2 digits to work with to make up all your numbers in binary, just zeros and ones. You've probably heard of that before. So that means if you only have 0 and 1 to make numbers, that means, well, 0 can be 0, of course, 1 can be 1. But then if you want to make 2 in binary, well, we've run out of digits in that place, haven't we? So that must mean 1, 0 is the number 2 in binary. And like, you can kind of see that, okay? So there's also another base system that kind of like assigns letters to all these. We'll get into that as well. But yeah, binary invented by Gottfried Wilhelm von Leibniz, because he invented a lot of cool stuff, all right? We'll also talk about logic in the class as well. Again, shout out if you have any questions, would like to comment on anything. That's how I want to run my lectures. All right, so that's the 1700s. Yeah. What's that? Someone's at the door? Okay. Where was I? So we're talking about binary and formal logic. Any questions about any of that? I'll teach you this in detail later, for sure. But yeah, let's keep on trucking. So let's next fast forward another century or so. A dude named Charles Babbage had this great idea to make a machine that you could crank. You could put in instructions into the machine, crank it, and it does work for you, which is very cool. This is like probably the first example of like a more modern computer. It was still not powered by electricity or anything, but this thing called the analytical engine that he came up with. He never actually built it, by the way. He just thought about it. It was too hard to build, but somebody eventually, after he was dead, went and built it, and it worked. But he had the idea of it. Okay, so it's called the analytical engine. What you could do is you could feed in to this machine a bunch of instructions. You could tell it what to do and in order to those things. Like thing 1, you could tell it to do something like this. Like, all right, add. It knows how to do math when you crank it. Add the results of the 2 variables, because it can store things in variables. Add the 2 x and y variables together and place them in the z variable inside the machine. All right? Like that's an instruction that you could feed into this. And then like step 2, then go and take the square root. I'll abbreviate like that for a reason, of that number z that we just calculated. And then step 3, maybe print on a piece of paper or like show in some way on the dial or something. Show the number z that we took so much care to compute. All right, so that's what the analytical engine could do. You can feed it in these instructions, you turn the crank or something, and it does those instructions in order to perform computation. Does that kind of make sense? That's programming in a nutshell. All right, so we'll get into that a lot more in the next lecture. So that was 1837. A few years later, a woman named Augusta Ada King, Countess of Lovelace. She was royalty. She had the coolest life, by the way. She was the first computer programmer. So Babbage just thought about the analytical engine, but it was Ada Lovelace who was the first programmer. She worked closely with Babbage and she came up with the first program to run on his analytical engine. So let's look at what she came up with. So the very first computer programmer, Ada Lovelace. I almost named my cat that. If my cat was going to be a girl, I would name her that. All right. So what it did is it computed the Bernoulli numbers. Have you heard of those? It's something that's used in mathematics and statistics. It's a useful sequence of numbers to have. And like here's kind of what some of these instructions, if you can understand them, if you zoom in far enough. But yeah, she had such a cool life. Maybe in English class, have we heard of the name? He was a writer, Lord Byron. Have you heard that word before? That name? Eventually, maybe in an English class, he was a famous writer. This was his one legitimate child, Ada Lovelace. He had a bunch of other illegitimate children, but she was the one legitimate one. So she had just a very cool life. She was also royalty and also the first computer programmer. So I love that about her. So yeah, that was 1843. And then fast forward another decade, so the 1800s, a lot of cool stuff in computer science. In 1854, George Boole introduced something that was named after him eventually called Boolean algebra. Right? So he made a way of doing math that works with not numbers, but with true and false. And true and false can also be thought of as 1 or 0. And there's a bunch of operations you can do on just true and false, and you could build them up together in these things called circuit diagrams to have it do something for you. So for example, there are a bunch of operations on trues and falses, or 1s and 0s. For example, there's an operation called AND. This is the AND operation. And if you AND 1 and 1 together, the answer is 1. All right, I'll teach you what that really means soon. But you can put a bunch of Boolean algebra operations on these ideas of trues and falses, 1s and 0s, together, and have them work together in these different operations and make a circuit out of it. And eventually, that will build a computer for you. All right. So all a computer is a big long circuit of Boolean algebra plus a clock circuit that goes up and down very fast every second, a billion times every second or so. All right. So that's very important. We'll learn about that. Do yell at me if you have any questions or want to comment on anything. Yeah, just giving you a little quick history lesson for the day. I think that's what I wanted to say there. Next, let's get into the early 1900s. Right? We started studying computation. We didn't quite build a computer yet, but we thought more about it. Babbage was the first one to think about it, and then we had more ideas, and eventually that culminated in something called the Turing machine. So it was invented by a very famous man named Alan Turing. Had a very sad life. Definitely watch the movie about him if you haven't seen it. Very, very unfortunate what happened to him, but he was super, super smart. And so what he did is he invented a mathematical model of computation. Any computer ever, what could it ever do? Right? Any computer that has ever been invented or will ever be invented can be modeled by this thing called a Turing machine. And so that's very powerful. We can prove properties about all right, what kinds of programs can exist, can't exist. And yeah, that's kind of what it looks like. I won't teach you Turing machines in this class, but it's feel free to look at the Wikipedia page. It's just it's a simple model of how any possible computer. It does it in a very simple way. It computes in a very simple way, but apparently you can prove that this does the same, eventually, as any computer ever could. It's pretty cool. All right, so that's Alan Turing. Turing machine, very, very famous idea in computer science. And so, still, nobody actually made a computer yet, other than Charles Babbage. He thought about one. I don't know if they built it at that time, but definitely not while he was alive. The first digital computer, though, the first one that was electronic, was built the same year in Germany. So this is called Z3 or Z3 probably because it was German. The first digital computer, so it's something that used electronics to do computation. It's a very, very big deal. Completely electric, no moving parts, a bunch of things called vacuum tubes that allowed it to do work and store information and do this Boolean algebra stuff using high voltages and low voltages. Really, really cool. Invented by a man named Konrad Zuse. And so, yeah, if you want to put this kind of stuff inside of electronics, what you do is remember that you have to somehow encode 0 or 1, right? 0 or 1 everywhere. Or that is false or true, right? That's another word for that. Inside of electronics, that means off or on, essentially. Off or on. Really, what I mean is low voltage or high voltage. That's how you encode it. There's still some power being passed along. So that's the first digital computer, and if you want to know more about that, you'll have to wait until CSCI 45. But super, super cool how to build a computer. You'll learn that in that class. But very, very important discovery and invention. It paved the way. All right, so yeah, we still get. It's just fun for me to remember all this cool stuff. Remind ourselves where we came from. So fast forward another decade or so after World War II, there was a very nice invention of something called the transistor. Have we heard that word before? Very, very important thing. The transistor is it's something small. It's something that's used in electronic circuits. And depending on who you ask, either they would say that, what is it? Antibiotics are the greatest invention of mankind. The other half of people would say that the transistor was the greatest invention of mankind that we've ever made. So it was invented at Bell Labs, which is a telephone company, because they wanted to make fancy telephone switching devices, which was cool to think about. But what it is, it's something you can include in a circuit, and what a transistor does is it's just a piece of electronics that can either amplify a signal or it can function as a switch, as a digital switch, and I will explain both of those now. All right, so for example, you may have heard of like the phrase transistor radio. That's a thing. Those were old radios, right? But what a transistor can do is you feed it a signal, so like some electricity going up and down or something like a radio wave, and it can amplify that signal. So that's what transistor radios do. So like it takes the baby electricity and makes giant waves that you could then like send to a speaker or something. So there's that. That's what transistors can do. They can also they're also in use in solid state amplifiers for guitars. So like I don't know if you've seen that, right? Electric guitars, they have pickups in them, which are little things with magnets, right? And your strings are made of metal, and so they're vibrating close to those magnets, and like just doing that creates a magnetic flux, which creates a voltage, which you can then feed into your solid state amplifier, and it will put sound out. So like you're making tiny amounts of electricity when you're using electric guitar and you're strumming it. So that's pretty cool to think about. And then you take like power from your wall outlet or whatever, and like you use that to amplify the signal. That's pretty cool, all right? But I do want to say that we don't actually care about any of that in this class. We don't care about the amplification part of transistors. What we do like is the switch, all right? This is the best thing for us. That's what computer scientists love that transistors can do. What this means is it's just like all a transistor is like an on-off switch that you can flick really fast electronically. All right. So what it is, it's essentially this. It's like a little switch, and depending on what you feed it, like here's a wire that's like not open right now, right? It's cut off. Like electricity can flow, and then it kind of gets cut off right there. It can't go anymore, right? And that's what happens if you send zero, low voltage, into this end of the transistor. So like there's this wire going that way, and then there's this wire coming in. And so if you send a zero, low voltage, to a transistor, it will keep that circuit open, and so no power can flow through. If you send it a 1, though, then it will close the circuit. It will close the circuit and let power go that way. And we can do that very, very fast, faster than you can flick an actual switch. All right, and that leads to everything. That lets you build a computer that's super tiny that can fit in your pocket. And that's why people think that some people think that the transistor was the greatest invention that mankind has ever made, because it's improved our lives so much. All right, so probably the coolest invention that I get to talk about today. Yeah, have we taken a physics class? Have we learned about this yet? It's fun stuff. If you want to learn even more, become a computer engineer. All right. I'm sad that I didn't get to learn too much about that in computer science. I wish I knew more. So, all right, a few more decades go by, and then we're like, all right, we got all these computers. We made them super nice and small. Like they used to be the size of this room, right? A computer used to be so big because before transistors, at least. And then we started shrinking them more and more because we could make these transistors super small, all right? And then once we had enough computers, we're like, it would be nice if I could send data from my computer to somebody else's computer. And so we started connecting them all together, right? We started networking them together. And so the very first thing was created by the government. It was called ARPANET. It was the thing before the internet. And so they started connecting a bunch of research labs and universities together. And here were the first 4 computers that were connected on this thing called the ARPANET. The third one on the internet, this is Stanford, by the way. Stanford, UCLA, University of Utah. And then UCSB, where I went to grad school, was the 3rd place on the internet. But I didn't study networking at UCSB. Maybe I should have. I studied something else. But yeah, it was the third computer on the internet was at UC Santa Barbara, which is kind of cool. So a lot of stuff happening in California. So that's cool. We're part of history, right? Then less than a decade later, transistors got so small and so cheap they could be mass produced that people are like, you know what? These computers that I have at my work that do all this computation for me, I think I would want one at my house. Why not? Doesn't need a super ton of power. Now that we've made these things so small, I want one at my house. And so the first true personal computer was called the Apple I. It was only sold to like 2,000 people. This is not what Apple is famous for, but here is an example of it. It's like a computer in the box. You bring your own display kind of thing. And it was invented by a very smart dude. His name is Steve Wozniak, that guy. So he was the other half of Apple. And then Steve Jobs didn't make the computer, but he did all the marketing, and he stole the fame, kind of. So that was the Apple I. Then the Apple II, the one that came after that, is the one everybody bought, and that cemented the idea that, computers in my house might be a good idea. Like, people could not imagine, they couldn't fathom the idea of having a computer at home, which is, I know, very foreign to us. But like, computers were doing giant, weird computations at their workplace, and like, I don't need that in my house. But then they eventually came around. They're like, all right, I can do spreadsheets and stuff. So they wanted to take work home with them. All right, so that's the personal computer. And that just like kicked it all off. Now we have computers that we have electronics that are so small, like this, right? My phone is more powerful than any supercomputer that was built in the 90s, for example. Like, that's crazy to think about, the way that we're going. And that's most of history. All right. So I do want to say, we talked about Ada, of course, the first computer programmer, but I do want to just emphasize the fact that computer science is not just a bunch of dudes doing stuff. We had Ada, the very first computer programmer. I just want to take one slide to highlight the works of women in computer science. All right. So some cool, very famous photographs, at least some of them. So the first person I want to talk about is Grace Hopper. She's no longer alive, sadly, but she was, I guess, what was her full title? She was Rear Admiral Grace Hopper. She was in the Navy, and she made some amazing contributions to what I studied in grad school. So programming languages and compilers. It's okay if you haven't heard of that second word before. You'll learn about it in CSCI 40 if you ever take that. But super influential on all of the programming languages that we have today. So like Python. We're going to learn about Python. We have Grace Hopper to thank for the way that Python looks today. Right? She was also the first person. The word bug was around just like to mean a problem, but she was the first person to use bug to talk about software, which is cool to think about. There's a fun story there as well. Her team found an actual bug inside of a computer, like a moth got into the relay, and it caused it to crash, which is cool to think about. So that's Grace. Then Sophie Wilson. Super influential. She helped design the ARM architecture, which is the backbone of all the newer Mac computers, and then every tablet and phone has an ARM processor inside of it. Those are better with power efficiency, and so we have Sophie Wilson to thank for our super fast phones in our pockets, right? So that's that. Shafi Goldwasser was a recipient in 2012 of what is called the Turing Award, which is the Nobel Prize of Computer Science. If you get that award, you win $1 million, right? It's really cool. So she got that for her work in cryptography. I'm not super qualified to talk about it, but definitely look her up on Wikipedia. And one cool idea that I kind of understand is something called fully homomorphic encryption. That's something that she helped work on. That's kind of the coolest thing ever. Definitely look into that if you're interested in cryptography. I think if we could ever make that quick, and we're getting better and better at it every year, it will definitely change the way that computation works. And then finally, let's talk about Margaret Hamilton. So this is a very, very famous picture. Have we seen this one before? So this is the one that you would have seen if you've seen anything. This is a super famous picture. She led the team that produced the flight software for the Apollo program. So we went to the moon because of her, right? She led the team, for example, that programmed the lunar lander software for Apollo 11. And so here she is a very famous photo. She is standing next to a printout of all the code that went into the lunar lander. All the code that she and her team wrote together. They just printed it all out, and it was taller than her, which is super cool. So yeah, super famous. Yeah, I just want to highlight the fact that computer science is not just a bunch of dudes. So yeah, I think that's what I want to say as far as history is concerned. Are there any questions about that? This a super little quick history lesson, exciting to talk about. Any questions, comments, cool things? All right. If we're good, I would like to segue into, I guess pretty abruptly, into a completely different topic. So I want to talk about ethics, because this is like the other half of this class, the critical thinking side of things. I want to talk about ethics and like social issues. It'll be pretty nice. All right. Here's some ethical questions for you. All right. We can eventually tie these into computer science. So here are 3 questions that we can ponder. Is it okay, for example, is it okay to steal to feed your family? Let's say that you have no way of getting food, otherwise, like everybody else has turned you down. Is it okay to steal to feed your family? Think about that. All right. How much? Let's keep talking. How much privacy should we have, for example, from our government, from other people, from our neighbors, from the websites that we visit who like track us around the internet? Like, what is the answer to this question? How much do we have? Total privacy? A little bit? None at all? That's an ethical question. It's a dilemma, right? And then finally, your standard trolley problem. Is it okay to kill one person if it means you save 50? So like there's 2 sets of tracks on a railroad, and right now the train is hurling towards 50 people tied to the tracks. Would you have blood on your hands and flip the switch and have the train, you can't stop the train, but you can divert it. Would you divert the train to a set of tracks where there's only one person strapped to it? It's an ethical question, right? It's called the trolley problem. All of these questions, I think you can imagine, there's no right answer to any of them, right? There's no way to answer this question and be like, oh yes, that's the right answer. I'm going to get 100% on my essay. That's maybe a little weird to some of us, right? A lot of the classes that we've taken up until this point is like, there is one answer, and I will regurgitate it right back to the professor, and I will get 100%. That is not what this class is about, at least this portion of it, okay? So there's no right answer. As long as you argue your point well, you're going to get credit. So yeah, we're going to learn about these ethical dilemmas, how to resolve them in our minds, and then we're going to learn how to make arguments, how to argue our points well. Was there somebody saying something? Sorry. Okay, yeah, arguing our points well, and ways that make good arguments, some good adjectives that describe good arguments. I'll eventually teach you, like an argument, we want it to be sound, for example. That's an adjective that describes a good argument. I'll teach you what that means. We want our arguments to be valid most of the time, etc. Right? So that's where we're going eventually. So it's kind of like 2 halves of the class, programming and then critical thinking, and eventually we'll have them come together, right? So I think that's what I wanted to say. So with that, I do want to talk about your very first assignment. So you got the check-in survey out already. Let's talk about your first assignment in this class. I will release it right now. It's going to be a little tiny essay, all right? So it's this one. If I click on it, I hope I did the due date right, but here it is. It's available to you on Canvas now. You can go and look at it, but it's going to be a little mini essay, all right? So I got a little prompt for you. I would like you to respond to that prompt in at least 250 words. So it's a very short essay to get us started with. Make sure you see the date, right? The due date is January 21st at 5 p.m. So that's next week, right? So next week, Tuesday. So you got a week and a day to do it, and here's your prompt. It's essentially me asking you these questions. So I know that this is so small of a word count, you don't have to like write a full essay with like an introduction and a conclusion. You can just kind of like respond to these however you see fit. Eventually I'll ask you to write like a formal essay. This is more informal right now, but here's your task, all right? I would like you to respond to both of these questions, all right, in at least 250 words. So I want you to respond to both of them, all right? So you might have to write more if you need to. Is it okay to steal to feed your family? It's your first question. And is it right to kill one person if it means that you'll save 50 others? That's your other question, all right? So I'd like you to resolve both of those ethical dilemmas for me, please, and just argue it in however way you want to. All right? Come up with an answer and argue it to me. I want to see where you are in terms of your arguing skills. Okay? Question? Yeah, that sounds like a good idea. Yeah, you don't have to do like a full intro conclusion, but I think 2 separate paragraphs would make sense to me. As long as I can understand like which one is answering which one's answering the other. I'm happy. At least for this essay. All right? Not this one. No, just like whatever you want to type it. I think I'll even let you. I think I'm forcing you. Can't even turn in like a PDF or anything for this one. Eventually you will, and that's what I'll have you do. But like I just want you to type into Canvas. There'll be a little text box, right? Yeah. So just remember that there is no right answer. Just like explain what you think and try to bash down the other side. So like if you think it's okay to steal or feed your family, tell me why the people who would say, it's not okay are wrong. All right? That's how you give a good argument. So do your best. I'll teach you more. I'll give you more firepower later in the class. But just make sure to give some reasons. Try to be convincing. I want to see where you are right now in your arguing skills. Any other questions about this assignment? So it's not too much. It'll be due next week. What I want to do though is give you time to think about your essay. All right. So I'll go back to the slide. What I want you to do after I let you do it is I'm going to get you into little peer instruction groups right now at the end of the lecture. All right, I want you to get together with the people sitting next to you. Please, after I explain, you'll do that. Get together with the people sitting next to you. Say hi. Talk about for a minute how your break was or whatever, and then introduce yourself, and then pick at least one of these questions on this slide to talk about as a group. All right, you can go through a bunch of them if you'd like, if you have the time. But what I want you to do is pick one of the questions at least and come up with, as a group, 2 arguments for it. So like, if you choose this question, an argument for that is saying like, yeah, it's okay to steal to feed your family. An argument against that would say, no, it's not okay to steal to feed your family. Come up with 2 arguments for that question that you pick and 2 arguments against it. So I want you to think about the other side, even if that's not what you think is true. Does that make sense? Think about both sides of the story because that helps you become a better arguer. And what I mean, at least for the privacy question, for means I want privacy, against means I don't want privacy, I guess. And then eventually I'll have you like write down your answers and share them with me on our class website. But for this one, I don't need that. Just save what you talk about for your essay. All right. So does the question make sense? That's what I want you to discuss. Please introduce yourselves first, though. We have plenty of time. And then go through at least one of these questions, come up with some arguments for and arguments against. And if you have more time, go through the other ones. All right? So yeah, take some time to do that, please, with the people sitting next to you.
I think the 2 questions I want to go for is the privacy and then the privacy actually takes really interesting for our own privacy. Any other places like then I think that's really interesting. I actually think that is on the right path, but it's dependent on each person's knowledge of their own privacy. And then for the trolley problem, there's the bystander clause where you don't want to get blown on millions, but there's also the millions for just trying to avoid it, as well as you could save 50 people and just be like one person that would still put blood on their hands. So yeah. And the interesting thing about stealing to feed your family, it's written, I think, in the first ever written law that you should not steal. And in the case that you're stealing, the person who's trying to sell this food, use this food to feed their family, stealing from another family, creating a sustaining like third graders. Yeah. You could also say that you're one of the 50 people. You could say that technicality, this person has like, say this person has a bomb. You could stop the bomb. You're one of the 50 people that get saved. How about that? For killing that person.
Yeah,
The same. What about privacy? California law dictates that anything that you visit on the internet says that you need to agree for the website to share your data. Oh, so every time you go to a website and you say like you accept our privacy policy on cookies, if you click OK, you're like okay, go ahead and share my data. That's why there's also in California most websites will say select other cookies, and there it'll be like, are you sure you want to get rid of all of our totally amazing cookies that are like we make the website better? No one all of it's like, are you sure? We want your money. Other states they don't. It's just like accept our rules in order to proceed to the website. Yeah. Like an advertiser's standpoint from websites, it makes sense. That's where privacy would be. It's like really good discussion. Otherwise, it's just information to advertise to the correct people. Like, are you on any sort of social media? But because of what you look at, it'll say, all right, this person looked at this nice auto shop, right? Okay, maybe they're in the hunt for a new car, buy a new rat or something like that. We'll send them some advertisements for this auto shop, this rat, or this car, and that's how they get their money. They sell your data. Advertisers to pay them to push their product. It's good for business and for personal privacy. All the incognito tests are not incognito because they still take your cookies. This location based on their IP, or they go to these websites, which this area because you're in this area, right? This area might have 1 minute. This bakery in this other town. To that area. Check out these cakes we got over. Everything you do online, there's a reason why everything happens. You don't just talk to someone, hey, I got this new dog, what kind of dog food do you recommend, or what toys do you suggest? And then all of a sudden you go look something up later and you get an advertisement for dog toys. That's not coincidence.
All right, friends, let's come back together just for a little while. Let's go back and talk to each other right after I get us out of here. All right, we still have plenty of time to discuss more. But I really like the discussions that I heard. Very nice. Hopefully, you found some nice firepower for your essay. Yeah, I hope so. Did any questions come up while we were talking that I can resolve? Like, are there any questions for me that you have after any of that? Yeah. Yeah. No. That's a great question. Let's see. I want to be as, at least as far as I am as a professor, I want to be as impartial as possible. But like, if you put a gun to my head and be like, all right, what is your answer? I would say totally, it's fine to steal. Yeah. Yeah. The markup. Are you saying? Are you saying that the item that you're talking? It was like. Ah, I got you. Yeah. Hmm. I think it still would count as stealing in my mind. But again, if you're gonna say like, what do you think? If I were in that situation, I would steal for sure. I think that would be my answer at least. Uh, I'm excited to hear what you guys think. Yeah. Any other questions? I do think that does count as stealing though. Let's see. Not to say that it's wrong. There's another question about like, should that item have been marked up so high? Like, is that really what it should cost? Is the other question. Then that's a question of like, do we like capitalism or not? And we don't need to get into that in this class. All right. So yeah. So that's hopefully helpful. That's what you're gonna write about. And yeah. I think what I want to say now is I'm going to stop the recording. Please talk to me if you weren't able to do the attendance. I guess let's do that now. Did we all do the attendance? Please raise your hand if you did not. And like I'll let it. Can I end it now? Or none of us are going to get dropped. Like, that's my question right now. We're good. Going once. Going twice. All right. You're all marked here. Cool. So we're just going to do that at the start of class from now on. And yeah, we have like 10 minutes left, so feel free to get back in with your groups, talk more if you would like. What I want to say is usually there will be some extra time at the end of class. I plan for that. And I just want to make sure that you don't, you know that you don't have to just go if you don't want to. The lecture is over, but the class is not. I am here until the end, which is 12:20, right? I'll be here. I'll let you stay if you would like to ask me questions, do your work on the big computers while there's still time, so that you don't have to go to office hours, for example. And I plan for extra time. I am not saying let's go if you don't want to go, okay? Of course, if you finish all your work, you're free to go. But yeah, usually there will be extra time, and I think that is all that I wanted to say and record today.